G'day. In this video, we're going to go over the steps required to communicate with a Modbus TCP device using Ignition. I'm going to be using this Groov EPIC Learning Center. It's perfect for learning more about Groov EPIC or doing a proof of concept project. I'm also going to be using this U.S.A P130 power meter as my Modbus TCP device. It's measuring the voltage and frequency of the mains power here in the studio. And our goal is to display that data in the Ignition Quick Client. To get started, you'll need the IP address and device ID of your Modbus device and the host name of your EPIC processor. You'll need the Modbus device registers, and this is usually found in a manual or supplementary manual for the device. Lastly, you'll need both devices on the same network as your laptop. Go ahead and open a browser on your computer and go to https:// the host name of your EPIC processor. Log in, and from the home page, select Ignition. The first thing we need to do is decide if we're going to run Ignition Edge or the full Ignition gateway. For the case of this video, either choice is equally valid. For help on choosing, visit opto22.com for a blog outlining the differences. Now once you make your choice, be sure and click on Save on the top right so that the gateway starts up. Once you have the gateway page ready to go, log in with your credentials or the default of admin and password. From the top menu, select Configure. Then on the left side, the subcategory of OPC UA server, select Devices. We'll need to add our Modbus TCP device, so click on the Create New Device button. From the list of devices, select Modbus TCP and then scroll down and click on Next. Starting from the top, we first give our device a name, optional description, and most importantly, the IP address of the device. In the case of our U.S.A, we need to adjust one of the advanced properties, so select that option to show them. We know from our U.S.A Modbus manual that the address range starts from 0, so we need to take the checkmark out of the base 1 addressing. Scroll all the way down on this page and click on the Save Changes button. You should notice that your device status goes from disconnected to connected pretty quickly, and if not, you need to check your IP address, port, and network options. To configure the register address, click on More and then select Addresses from the drop-down list. On this page, we need to click on Add Row. Now it looks a bit overwhelming, but let's just go through them one at a time here. Prefix is the name of the register contents. In my case, I'm going to first read volts, so I'll enter the word volts. Start and end are the number of addresses you intend on getting. In my case, I want just the 1 voltage register, so it will start and end at 0. But let's just say I was getting 3 phase volts. There, I might enter 0 and 2 to get the 3 registers with each phase voltage. Step is if you're going to be combining 2 16-bit registers into one 32-bit register. Unit ID is your Modbus TCP device unit ID. Check your device configuration to get that. In my case, I know it is unit 1. Modbus type has lots of options, but it will tie back to your device manual. In my case, from the U.S.A manual, I know that the raw counts for the voltage are an unsigned integer 16-bit register. Again, from the device manual, I know that the voltage address is 256. Now, RAID-X determines what format addresses in the device are labelled. Common values are 10 for decimal or 16 for hexadecimal. Let's quickly add a row now for frequency. Hertz for the units, getting 1 register, unit ID of 1, it's also a 16-bit unsigned integer, and its address is 279. Now we can click Save and we're done with the configuration. To check for our data, we can use the built-in Quick Client. Under OPC Connections, click on Quick Client. Drill your way down to your device by expanding the little pluses, and the two tags we just added will show up. Click on the small R to read the data in raw counts. From here, it's up to your process requirements. You could be building a screen in Ignition Designer or sending the data via MQTT to another client. And in each case, there would be a different method to scale the raw counts to engineering units. For more information, check out training.opto22.com. Thanks for watching. Cheers, mate.